All right, we're going to go ahead and get started. On behalf of Applied Fluid Power, I extend each and every one of you a warm welcome and thank you for taking the time today to attend the webinar. We are excited to announce the launch of our newest product, Applied Fluid Power Connect, a complete IoT telematics solution to meet the demanding needs of the mobile and industrial fluid power marketplace. My name is Adahm Faehn, P1 Integration Specialist for Applied Fluid Power, and I will be your host for today's webinar. So our agenda for today is we're going to talk about our ecosystem diagram. We're going to talk about what is telematics, how does telematics work at a fundamental ground level. We're going to talk about how to install our solution on your machine, whether it's an existing machine or a new machine. We're also going to talk about how we can flash ECUs or controllers that are on your machine remotely. Then we're also going to talk about how to update displays or operator machine inputs. Then we're going to talk a little bit about the different three tiers of solutions that we have, tiers 1, 2, and 3, and how they might best suit your application. And then what are the benefits for each of the different users that would use our solution. And then ultimately, we're going to talk about how you can get started with Applied Fluid Power Connect. All right, so let's talk about the ecosystem of Applied Fluid Power Connect. At the heart of it, it's really three main modules. On the left is going to be your equipment, which is going to be controllers, engines, other HMI displays that you might have on your system. We're going to ultimately connect up our hardware, which is what you see kind of in the middle tier here, which is our telematics. That's going to be what we call our edge hardware, which is going to be connecting into CAN bus or just directly into other sensors that you may have on your machine. All that is accessible through a 4G connection through a World Wide Web portal that you can access, also accessible via Wi-Fi. And then on the right, kind of the third module of this whole system is going to be our analytics platform, business intelligence, business analytics. And what that's going to do is that's going to give you insights onto how your machines are operating. It's going to give you insights into a scoring system. It's going to be able to give you the ability to rate different machines, but then look at trends, year over year, KPIs, and ultimately establishing a benchmark for your product. So another way to look at it, we have all of our cloud services, which are going to be on the top. That's going to be our portal. We have all of our back-end servers that are going to be there. This is where we're going to access all of the data that the machines produce. This data is 24/7, 365 available, accessible through smartphones, tablets, laptops, whatever, and can be shown in any one of many different ways. We can show bar graphs, we can show history graphs, we can show pie charts, whatever that may be, but that's all going to be our cloud area. We have kind of our transmission layer. So here again, as I had mentioned earlier, we have accessibility through 4G LTE, through a Wi-Fi router, and then what's not shown here is 3G and 2G fallback to, just in case 4G is not available. But as far as our edge hardware, we've got several different devices that we can choose from depending on your application, all the way from very high-end devices, which have upwards of 4 different CAN bus networks that they can talk to. They can communicate over Ethernet as well. Several different antenna options depending on where you want to physically locate this on your machine. We also have middle grade options for maybe you don't need 4 CAN buses and maybe you don't need some of the features that we offer there. So we have some mid-grade options as well. Some of them also do have battery backup, so you can still see where that machine is at and have a GPS location even if the machine is turned off. And then we also have entry-level devices, which are pretty much going to be, select an input, select a scaling, a min-max, and start seeing data, in under 10 minutes or less. And then all your machines at the bottom there, all of our products are intended to be just easily added to your machine, wired up, and starting to see data very quickly. So I'm often asked, how does the Applied Fluid Power Connect system actually wire in and communicate with my existing hardware? So in this diagram I'm going to show you here, we have machine level electronics, which could be a traditional ECU. We've got a Tier 4 J1939 engine, and we have an operator display that would be in the cab. In this case here, I'm going to show you, we're actually using 2 CAN buses here. One of them is J1939 enabled. So really what we're going to do is we're just going to wire the applied fluid power system into both CAN buses in parallel. So at this point here, the system is just going to be listening. That can be done a couple different ways. That can either be hardwired into the system or it can be done very simply through just a diagnostics port. Either way works just fine as long as we're wired into both CAN buses. So in a system like this, there's going to be a lot of information going back and forth. There's going to be control messages going from the controller to the engine, maybe for example, telling it what target engine RPM we want to be at. There's going to be a whole bunch of information from the engine going back to the controller, maybe some regen status, maybe some torque values, some coolant temperatures. There's a whole wealth of information depending on the engine and the engine manufacturer that's going to be going back and forth. On the display, there may be a whole bunch of IMIN, IMAX values. There's going to be operator inputs. There's going to be settings. There's going to be control values. There's going to be a ton of information going from the display back to the controller. So really, along with that, we could also look at valve commands, operator inputs, sensor values, and then here again, other diagnostics information, maybe like DM1 messaging. So when a message does come across the bus, in this case here, this green envelope message, when that does come across the bus, if that is a message we have configured the telematics to look for, it's going to unpack what that message is, and it's going to read the information inside. So in this case here, if we've configured the telematics box to look for engine RPM and engine torque, when it receives a message that matches that filter, it's going to go ahead and decode that. And then from there, it's going to take that information and put that up into the Applied Fluid Power Connect database. Here again, giving us accessibility later through the portal. So as far as what hardware we can talk to, right, being that we're just communicating over J1939 or CAN, we have access to tons of sensor information, whether that's pressure, flow, temperature. Some of the other things that we can pick up on would be, system commands and feedback from Propel systems. Other advanced controls like radio remotes, maybe like an RFID reader, for example. Another one would be just other controllers in the system. There's a lot of information about settings and control that's happening in between multiple controllers that we can pick up on. We covered displays. Another one would be smart valves. A lot of these valves are now CAN bus driven, so we can pick up on what the driving commands are and what feedback is as well. And then, of course, engine and transmission information as well. So now let's show you how that works in the real world. Hello and welcome. In this video, I'm going to show you how to connect your new Applied Fluid Power Connect IoT system to your machine. First thing you're going to want to do is find access to power, ground, ignition, and any CAN buses, typically found underneath the access panel just like this. On this machine, you can see that we have access to several different CAN bus networks, power, ground, and ignition. This would be a good place to start. I'm going to go ahead and open up the top of the operator control panel here, just so I have a little bit more room to do my wiring. Alright, so now you're going to want to grab the gateway, the telematics box itself, the single antenna that has the 3 connector ends on it, or the dual antenna that actually has 5 connections on it if you ordered that model. And then of course the lead wire harness that comes with it too. Go ahead and collect that and get that ready for the next step. Alright, so now we're going to go ahead and prep the wire harness. In this case here, I've got a whole bunch of the inputs and the outputs wire tied together because in this installation, I won't need them. Over here though, I do have power, ground, and ignition zip tied off here just for simplicity. I'm going to go ahead and remove these zip ties and use this in the installation. Now on the CAN bus wires, the CAN bus are going to be the gray wires you see here. The beige will be the USB. We're going to get this ready for the installation as well. And as you see here, I even labeled each of the wires as to how I wanted to install them. And here's a USB. And this end goes to the TCG4. So the wire harness is actually inkjetted on each of the wires that matches the pinout in our catalog. So we're going to want to locate wire 10, wire 8, and wire 9. 8 is power, 9 is ground, and 10 is ignition. So now we need to locate the power, the ground, and the ignition wire on the machine. This is very important as it helps us program our sleep functions and make sure that we do a proper shutdown on the box. So here we have constant 12-volt power, on or off no matter what the machine is. And this one here, we've got an ignition wire that is on and off with the key switch that you see here. This is very important to make sure that we wire this up and not just kill power directly to the box. So let's go ahead and start wiring up some of the CAN bus networks. In this case here, I'm going to be wiring in Deutsch connectors, but that could be different depending on your machine. So this example here, I'm wiring up just one single CAN bus network, but you may have up to 4 depending on your installation. So now go ahead and take the connectors that you just made and go ahead and plug that into the machine CAN bus connections. If you have a machine that is using a USB connection, go ahead and plug that in now as well. Alright, so let's go ahead and start wiring up the antenna. So on the side of the TCG4 we have a 4G port, a diversity port, the GNSS or GPS, and the Wi-Fi Bluetooth port. If you order the dual antenna, you're going to notice it'll be 5 wires. The blue one here is GPS. You'll have 2 LTE ports, which are 4G, and 2 yellow Wi-Fi ports. Right now the second Wi-Fi port is not used. If you order the single antenna, you're going to have 3 wires to look at, same color coding, just 1 of each. In this case here, the diversity port would not be used. So let's go ahead and wire up the dual antenna. The blue GPS is going to go to the GNSS port here. You'll want to make sure that these connections are finger tight, but not too tight. There we go. LTE1 is going to go directly to the 4G port. Here again, finger tight. Same thing here with LTE2 into the diversity port. And this really gives us dual band 4G capabilities by having the dual antenna. And last but not least, the Wi-Fi port. Wi-Fi and Bluetooth combined in the same wire. And Wi-Fi 2 is not used in this installation. Alright, so now let's go ahead and connect the TCG4 and the wire harness together. Line the pins up as you see here, slide it in, and push the clip in. It does take a little strength to be able to push it in, but push it in until it's... So now go ahead and apply power to the box. You'll notice the 5 green lights at the top will come on, along with the status light. So this concludes our initial wiring video of the Applied Fluid Power Connect IoT system. Thanks for watching. So with Applied Fluid Power Connect, not only can we connect to your machines and see locations and variables, we can actually also flash controllers as well. We support many different controller manufacturer brands. The one I'm going to show you right now is the process to flash an STW controller. So let's just say you have a programmer's laptop and then you have a controller on your machine, which you see here on the right. Adding in Applied Fluid Power Connect gets you the hardware that connects to your controller through a CAN interface, along with the portal here at the top. Go ahead and establish an internet connection between your programming laptop and Applied Fluid Power Connect, or log in, and then establish the cellular LTE, 4G, or 3G network that's required to connect your machine into the portal. So now what you're going to need is you're going to need an update file. So depending on the controller, this could be an update package, or it can just be an APP or hex file that comes from a programmer's laptop. Now it's important to note it doesn't need to be the programmer that does this. This could be something that one of your technical support people does for you. But either way, start with that file. That file then gets uploaded to Applied Fluid Power Connect through your internet access. Down to the device itself. Now I'm going to stop real quick. It's important to note that this is not a direct connection to that controller. So if you go ahead and upload that file and because of a poor internet connection it takes a while, that's okay. It's CRC redundant checked to make sure that we don't have to establish a continual link during this process. Each stage is checked. So from there, through the CAN interface, that program is flashed to the ECU. Upon successful completion, you'll get a notification back to the programmer's laptop. Now this process, depending on file size and program size, is usually about a 2 to 3 minute process. So here again, why would you travel all the way out to a machine just to program or just to hook in one programming cable when you can just do it remotely? So in my programming environment, what I'm going to do is I'm going to create an update package that we can put into the portal. So in this case here, I'm going to go ahead, save this new support package, and save it to my local computer. Here again, this can be uploaded by me as a programmer, or it could be done by your tech support group. Okay, so once you've been logged onto the portal, go ahead, connect to your device, and under your device's settings here, look for this flash loader icon up at the top left. Go ahead and accept the disclaimer, and go ahead and pick your controller. So from here, you'll have a couple settings you need to answer, what type of flashing it is, which CAN bus you're connected to. But in this case here, I have that already set, so I'm going to go ahead and import my file. There it is. And I'm going to go ahead and hit flash now. But before I do, I did want to bring note that this is our controller here that I'm going to show you as a demo. I've got the status lights for the telematics box here as well that you can see along with the status lights here on the controller. All right, let's go ahead and flash. So at this point, what's happening is that it's going to take that file off of my laptop. It's going to upload to Applied Fluid Power Connect. Once that upload is done, completed, and checked, then it's going to send that file down to the actual device itself. Once that happens, then it will start to initiate that transfer, that flash. All right, so now that the system update was successful, it's going to go ahead and cycle the controller. The controller is going to come back up into its run mode, and the programmer or whoever is actually running this in the portal is going to get that system reset successful message. So now that I've shown you the process to flash an ECU with the Applied Fluid Power Connect system, let's go ahead and show you the process to update a display through the same system. So let's go ahead and remove this controller and put a display into this diagram. Now it's important to note it does not have to be just a display, but anything that is updated via a USB stick. So let's take a USB stick coming off of a programmer's laptop. The program is compiled, it's put onto that USB stick, and that USB stick then is transferred to the display. Typically on the back of a display in the wire harness there is a female USB connector that USB stick plugs into. And generally the update process, now this is dependent on the manufacturer, but generally the update process is done by holding a button and either powering up the system or doing some other sequential input to get the display to read from that USB stick. Once that's done, the program is updated. So now if we run through the same process with Applied Fluid Power Connect, let's go ahead and put in our system that we showed you before. Same hardware, same portal, same connections, but this time, let's go ahead and let's add a USB interface. So that same file is created on the programmer's laptop, and it's uploaded to Applied Fluid Power Connect. Now it's important to note that the difference in this is that that file is then held in a profile in Applied Fluid Power Connect. So that profile can be an entire fleet of machines. So when the gateway comes online, that gateway is going to notice that there's a file available, and that file is going to get transferred to the gateway to its internal storage. Now the display does not need to be on at this point. The only thing is that the gateway needs to be on to grab that file and keep it in its internal memory. Now anytime that the display is on and that same sequence is carried out, so in this case here pushing one of the buttons, that file is going to get pulled over to the display and that display is going to get updated. So quite a few of the wire harnesses that we offer as well do have that USB pigtail already in them. So this process is as simple as uploading your existing programming file to the portal. There's no extra scripting required to do this, and the wiring is already done for you there. You just take that USB wire that you see in the picture there and plug it into the back of the display, and everything else is handled for you. This can be a very efficient way to release a new update, a new software update, and have it pushed out to your fleet of machines as the machines come online or as you desire them to be rolled out. We can also add some additional functionality that we send a message to the display to replace that finger push there that you see to get the display to update automatically. But either way, it's simply uploading a file into Applied Fluid Power Connect and you have your fleet updated. So now I just want to give you a high-level overview of what the portal looks like with Applied Fluid Power Connect. So when we first log in, we're presented with this map view. From the map view, we can see the locations of all of our assets. And we have some simple filters here that we can choose to turn on or off. So the whole goal of our system here is to make it where it's easy to find information that you need quickly. Rather than having to search asset by asset, we want you to be able to go in and find machines that have issues very quickly if need be. So one example here is if there's any machines with active alarms, I can click on them, I can find that machine, and by clicking on that, I can go directly into that machine without having to try to find it anywhere on the map. All I had to do was just say which ones have active alarms. And based on this, I can see right here, I've got a couple of DM1 faults. So we'll talk about DM1 faults here in a little bit, but very quickly within 20 to 30 seconds, I can find what machines need my attention very quickly. So if I go back up here, we'll turn our suborg assets on here again. Here again, the whole goal of this was to make it easily searchable. So if I know that there's a machine I want to look at, let's just say this machine here, I can click on it and I'm easily presented with up to 5 parameters that are on that machine, and this is configurable by you. What's the 5 most important signals that you want to see just from the map, and just by clicking it, I'm presented with those values. Now I can see that this machine is currently offline, but as we talked about earlier, this accesses everything in the database, so I can still click on this asset and I can still see information off that machine. So I can see GPS location, I can see some engine information, I can send some commands down to the machine if I want to. So in this case here, if I wanted to do a template update or log all the signals for a couple minutes, I could do that. So here again, two-way communication with the box. And then just some simple metrics in a whole bunch of different ways to see it. So we've got gauges, we've got bar graphs, we've got pie charts, we've got a lot of different things that we can show here. So let me just show you real quick. If I just wanted to add a simple tile for engine, let's just do like a little gauge that shows engine hours per se. So if I come in here, I just want to show a gauge. I want to go and find engine hours, which is right here, engine hours. And let's just say I want that to be up to 25,000. We'll call that engine hours. So now the next time that that machine comes online, that information will start to populate into that tile. Now the other thing I did want to show you here is we can historically go and look through our little calendar icon that we have here, and we can look at the last 1 hour, 3 hours, or 8 hours by default. We can look at information that's happened over those times. Otherwise, we can come in here into this custom area, and ever since the machine was first commissioned, we can go back and look at whatever date range that we would like. So here again, this is just accessing all the information back in the database. Very powerful to be able to go back and troubleshoot what was happening to a machine a couple days ago, a couple weeks ago, or even a couple months ago. So now what I'm going to do here is we're going to go into an organization, and an organization is basically your company. So from this view, we've got 5 different areas here on the left. We have our assets, which are going to be all the individual machines that we have at our level, and we can see whether they're online here or whether they're offline. We can see a rough location for them, and then what asset model they're tied to. And an asset model is basically like a machine model, right? So if you have an OEM that has 10 different machine models, you would have an asset model for each one. I'll show you what that looks like here. So in this case here, we have some templates here for, for a bulldozer or for, a backhoe. We've got several different machine models here that we have as an example. And each one of these would have information on what CAN bus messages, what parameters, what, how we want to track information on that machine. We have geofences here, so if you want to log when a machine comes in or out of a specific area, you can click on that You'll get alerts based on that depending on which machines you tie that to. And then suborg. So this is where you start to manage some of your dealers, some of your OEMs, and this just allows sharing of user logins, information between portal templates, data, whatnot. It's all being able to, push down to different OEMs, different dealer networks, so they can manage their own groups and see what their machines are and have their own map. Okay, so the next area I'm going to cover real quick here is going to be the events area. So now here again, as we talked about, the power of our system is not having to go through and look at every single machine and see, okay, is machine A good today? Okay, now let's look at machine B. Now let's look at machine C. By simply going to events, I'm now looking at the events for my entire fleet. So right here, I can tell you I have 17 active alerts, and I can see exactly which machines. Now in this case here, it looks like it's one machine that's a repeat offender, and you can see very quickly what is that error. The other thing is you can see when that trigger was detected at, and then the other thing is that you can actually see a GPS location. So oftentimes as we're troubleshooting machines in the field, a customer will say, well, something happened yesterday. Okay, where were you? What were you doing? What were all the values at that time? Being able to come in here and just click on this gives you the ability to see, okay, where was the machine when this happened? So DM1 fault, so this is, engine check light, diagnostics, messaging type stuff. Here again, I'm looking at this for my entire fleet. I can see that across my entire fleet, I only have 2 active DM1 faults. Only one machine has those faults. Here again, it's machine 2. And I can quickly see here what was the source. So in this case here, it's from the endurance braking system and then the ignition control module. All right, so now I'd like to take you into the maintenance area. So we've got 3 areas of maintenance. So we have our maintenance dashboard. So here again, this is going to give me a global view of all of my assets, all of my dealers, all of my end customers as far as what the maintenance requirements are for those machines. So you can set up certain requirements, which I'll show you here in a moment, certain requirements for a machine model as far as what maintenance is required. You can also tie it to parameters on the system. So if you have like a filter life signal on there, when that life goes below a certain value, you can trigger some maintenance to be done. But from this page here, you can quickly see, okay, what machines are overdue for service, what machines are up and coming for service, what was the last service date, and then we can also tie different parts to each of those service modules so we can get a projection of what the aftermarket parts revenue is going to be. So very powerful for the purchasing and operations and service people to be able to know, okay, what machines are up and coming due for service, and then we can ultimately click into any one of these and see what service has been done already. So let's just do that real quick. So you can see here, this gives you, kind of like just a historical reading, almost like a Carfax report for all of the service that's been completed, along with when it was completed. So if we look in the schedules area, this is just going to be some examples of schedules you can set up for each machine. You can tie each one of these to whatever machine you like, but you can create as many maintenance schedules as you want. If you want, maybe a 100-hour inspection schedule, and then maybe you want a 500-hour engine oil change schedule, you can easily program that in here. And then as I had mentioned earlier, all the parts can be tied into this as well. So if there are parts that you are selling at the OEM level or at the dealer level that go in with any of those services, so in this case here, obviously with an engine oil change, you can tie an engine oil container to that. So it gives you lots of flexibility to tie any information into that maintenance module that you like. All right, so we offer 3 levels of solutions with Applied Fluid Power Connect. Level 1 is going to be your basic level. This is really intended for industrial type applications, and with this you're going to get predictive maintenance, you're going to get basic alerts, notifications, and some performance reporting. This device is going to have 4 analog inputs that you can log, along with some additional communication parameters, but it's really intended to be configured with a smartphone app and gets you quickly up and going and gets your toe in the water on IoT. Moving up from that feature, we move into what we call our medium level. The medium level starts to add in CAN bus functionality, starts to add in some J1939 communication, and provides a little bit more on the historical data area. We start working with fleet reports. We can work on doing fuel usage, operation metrics, and utilization metrics as well. And then for customers that might be in like a rental market type application, we also offer the ability to send messages from the portal down to this box to either enable or disable features that might be on a controller that's already on the system. The top end is going to be level 3, which is the high-end solution. This is the Applied Fluid Power Connect top end. This is going to up it to 4 CAN bus connections. It's going to give some level of Ethernet Modbus support. It's also going to support any of the ECU flashing that we talked about a little bit earlier in the presentation. It's also going to give you the ability to update displays via USB and any other devices that can be updated via USB. We also introduced what we call our advanced sleep mode. So the device can be sleeping and it can still log some simple data. It can also wake up every so often and report values back into the portal, and then expands out to roughly 8 gigabytes of onboard storage in case you're in an area that does not have a cell phone connection. You can continue to log information to this box until that cell phone connection has been reestablished. We also have the ability then to write custom apps, so that way if any of the features that you see here don't quite meet your application, we can build in additional functionality to meet your application. So just a little recap. So a couple of things that we just covered there in the portal overview. So engine diagnostics, messaging, logging, and reporting. So here again, this is a feature that it's just a selection within our portal. Turn it on, turn it off, and just indicate exactly which CAN bus your J1939 engine is connected to. The DM1 messaging is a standard J1939 protocol, so there's no extra scripting or heavy lifting that has to be done. You just turn it on for that machine. And in this case here, you can see that we have information on 2 DM1 messages that are active on this machine as it sits today. So very powerful as we continue to, troubleshoot and monitor our fleet of machines. So the maintenance schedules here again, you can go through and create as many as you want. So in this case here, for this customer, I created 6 of them. These can be tied to any of the machines that they have in their fleet as well. So here again, not having to log any of this information on an Excel sheet or have to try to maintain this in a logbook on the machine. We can maintain all the logbook information right in the portal. And then the last piece here, just the maintenance schedules and aftermarkets parts. So incredibly powerful thing to help bring customers back to you as far as aftermarkets parts, to make sure that they're buying the correct factory authorized part as well. They're getting the right part, they're getting it at the right time. You know that if that part is coming up and due for replacement soon, you can make sure that you or your dealer or your end customer has that available on the shelf ready very quickly. And then you can actually attach your quote or an invoice to the email that customer would get, giving them all the parts and prices that they would need to go ahead and get that on order, or if not, already have it on stock ready to go for you. So as we think about IoT, we definitely want to make sure that we don't think of just the engineering and just being able to connect to a machine and do some troubleshooting, right? There's really value for the equipment manufacturer, the dealer network, and then of course the owner / end customer, right? So we can talk about things like operative effectiveness. We can talk about aftermarket sales, enhanced service intervals, for example. So are we doing service intervals based on time, or are we doing it based on actual machine need? We can see what check engine lights, engine diagnostics are happening across our entire fleet. And then, another one would be, a reduced warranty claim. So if there's a continual part within your fleet that is continuously failing, you can go back and look at the historical data. Well, what was the machine doing that led up to that failure? So very powerful. I think this also creates a really strong bond between your dealer network, up to the equipment manufacturer, and then of course also down to the owner. So it allows that dealer to provide better remote field service capability. So being able to log into the portal, here again, seeing what information is on that machine, gets you to a solution for whatever issue might be on that machine quicker. For the owners, you can see what kind of behaviors the machine is doing. So, the machine should have started at 6 a.m., but maybe it didn't start till 8 a.m. When we talk about like a utilization and efficiency, how often is that machine actually running? How often is it actually doing work versus idling? and then what was its actual available time. Maybe it was at a job site for a month, but it never actually ran except for maybe one day out of that month, right? So we would consider that, low utilization, right? So through that, you get a really clear picture about what your machines are really doing. But here again, it's not just one machine just connecting to and seeing information about code assist parameters. It's understanding how the machine is really working out in the field, but really moving towards the power of the fleet. So I would ask you then, so what are your IoT goals? What out of this diagram here could we best help you with? So if you haven't already, I encourage you to go to our website, appliedfluidpower.com, and you'll notice here that on the slider we added a completely new area about Applied Fluid Power Connect. If you click on the Learn More tab here, you can see a whole bunch of information that we just covered on the webinar today. Along the top here under Internet of Things here, we have areas about functionality, features, and benefits. So some of the features that we talked about in the webinar here, we talk about a little bit of the diagram about what IoT and Industry 4.0 brings. We talk a little bit about some of the over-the-air programming, some of the flashing that we covered with the USB displays along with the controllers as well. We talked a little bit more about some of the geofencing and some of the critical information on how we're storing it. We talk about, operator activities and compliance as well. But if you want to see a customer that went through this process, you can download this entire full case study here as well. This is available to you to kind of see what the start to finish process looks like. And then let me just cover this real quick here. If we go back up here to benefits, we talk a little bit about, what I just covered there about benefits for you as an OEM, some of the things that might be closest to you. We talk about some of the benefits for your dealer networks as well. So some of the things to start that conversation about, how can we improve your operations as a dealer? And then of course, benefits for the end users as well. So I know we covered a lot here. We're excited about it. We're hoping that you're excited about it as well. So we encourage you, if there's anything in this webinar that has piqued your interest, to go ahead and fill out this contact form here as well. We'd love to be in contact with you shortly.